Hey guys, welcome back to the continuation of the concept of unsaturation detection. We were dealing with organic compounds and those compounds which have unsaturation, how to detect that unsaturation. Guys, there were different types of the compounds. I would like to remind you that there is one category which is carbon-carbon single covalent bond. These compounds are considered as alkanes. Their names have a little bit difference. The second category is carbon-carbon double covalent bond. These are unsaturated and these are called alkenes. And there is one more, and that is C, triple covalent bond C, and that are called as alkynes. So these are the unsaturated ones, whereas alkanes are the saturated compound. Guys, I would like to inform you very clearly that alkynes are not part of your syllabus directly. Alkenes are part of IGCSE, GCSE, and this GCE as well, O levels. Okay, so remember this thing that alkynes are not part of your syllabus directly. Okay, so this is what is called as unsaturation and saturation, which we were dealing in the previous lecture as well. Here we have a topic that is passage of hydrogen through different oils and identification of degree of unsaturation. Okay, guys, this is basically a past paper question. I will change the board now, and here on this page I am going to explain you that, for example, examiner is giving you different type of oils and he's saying that A is palm oil. Okay, A is palm oil, B is coconut oil. Okay, and C is mustard oil, for example, and D is vegetable oil. Okay, so he has taken four different types of oils, the option A, B, C, and D. And now he is saying that 100 centimeter cube of hydrogen gas is passed through all of them. Okay, you have to tell this thing that which one of them has the highest degree of unsaturation. Guys, which will decolorize the liquid Br2 to the highest level. Similarly, which will consume the highest volume of hydrogen gas, they will be considered as the ones which will have the highest degree of unsaturation. So for example, if we are talking about palm oil, we are saying that 56 centimeter cube is left after passing 100 centimeter cube. Okay, in case of coconut oil, we are saying that 38 centimeter cube is left. In case of mustard oil, for example, we are saying 70 centimeter cube is left. In case of vegetable oil, we are saying that 50 centimeter cube is left. Okay, the point number one is this, that all of them are unsaturated. Why all of them are unsaturated? Because all of them are consuming hydrogen up to a smaller or to a larger extent, but they all are using it. Okay, so they all are considered as unsaturated hydrocarbons. If they would not have any carbon carbon double covalent bond or any carbon carbon triple covalent bond, in that case they will not consume a single centimeter cube of hydrogen gas. Okay, here, as they have consumed different volumes of hydrogen gas for their reaction, so as a result of that, it is giving us an evidence that all of them have little or bigger level of unsaturation. Okay, now, examiner can ask this question in two ways. Number one way can be which one of them is having the highest degree of unsaturation. The one which has consumed the highest level of hydrogen is having the highest degree of unsaturation. Just imagine 100 centimeter cube of hydrogen is passed through coconut oil and only 38 centimeter cube is left, whereas the remaining volume has been used by coconut oil. So it is just telling you that coconut oil has released the least amount of hydrogen gas out of it when 100 centimeter cube is passed through it. So it is just giving you an evidence that coconut oil is the most unsaturated. And then he is asking which one of them is the most saturated, for example. Okay, then this is the most saturated. Why it is so? See, why it is so? Because it is releasing 70 centimeter cube. It is just consuming 30 centimeter cube of hydrogen gas. So the one which is consuming the highest volume is the most unsaturated, and the one which is consuming the lowest volume is the most saturated one. So these are the two limits, these are the two boundaries, and you should know this thing that out of 56 and 50 centimeter cube, the one which has released more volume is saturated, and the one which has consumed more volume is the more unsaturated one. So these are the concepts related to unsaturated and saturated, and saturated and unsaturation test can be done with the liquid Br2. Whensoever examiner is asking you how to identify unsaturation, or how to determine that this compound is unsaturated, and what is the answer that we can identify, we can determine the presence of unsaturation by passing it through liquid Br2. Then you can say this thing that liquid Br2 is a red brown color liquid, and when this red brown color liquid will be passed through any unsaturated compound, any alkene, in that case we can say this thing that liquid Br2 is undergoing a color change, which is just determining that liquid Br2 is the source for determination of unsaturation. Why? Because there will be a color change. Higher will be the color change, higher will be the degree of unsaturation, lower will be the color change, lower will be the degree of unsaturation. So this was the whole detail related to unsaturation. Okay. Guys, I would like to bring your attention on the previous lecture as well. Before this, in this lecture, we have just studied the unsaturation. Here, I have discussed with you the some of the past papers, and I would like to bring your attention back to the topic of organic chemistry, which is just telling us that what are the different types of the reactions of alkanes here. So afterwards we move to alkenes, and the reactions of alkenes are left. Now we are going to study the reactions of alkenes now. Okay, guys, I would like to bring your attention to the concept that in case of alkenes, if we are talking about the reactions of alkenes, there will be addition reactions. Okay, guys, here I'm going to write down the heading reactions of alkenes. Okay. One thing which I would like to tell you again, alkanes had what? Carbon-carbon single covalent bond, and these were called as saturated hydrocarbons. One more thing which I would like to inform you, all alkanes show substitution reaction only. Okay, only. Be very careful. Okay, now I am telling you that alkenes, which are carbon carbon double bonded compounds, they will show addition reactions. Addition reaction. So guys, please be careful about these two and differentiate between these two as well. Okay, it is not very difficult to keep that thing in mind. If you are going to keep that basic concept in the mind, then things can become easier. What is that concept? Alkanes have already carbon carbon single covalent bond. They have already made all four bonds. Carbon has already made four separate single covalent bonds. Hence, whensoever in case of alkanes there will be a reaction, one has to go so that carbon can welcome the other one. That is called as substitution reaction. In case of alkenes, as carbon is making a carbon-carbon double covalent bond, in this way, whensoever a new one is coming, as a result of that, this carbon-carbon double covalent bond will be shifted into carbon-carbon single covalent bond, and the incoming partner can be attached with it. We can say this thing that in addition reaction, there will be two types of the reactants which will combine with each other to give one type of the product. Okay, so that is called addition reaction. The two reactants are getting adding up into each other. They are becoming one. Okay. Now I would like to tell you that there will be how many types of the addition reaction. Number one, hydrogenation. It is just the addition of hydrogen. Hydrogenation. Number two is halogenation. What is halogenation? In which halogen are being added. Number three is just the addition of water. I am writing it very clearly. Addition of steam, by the way, I should say, because temperature is quite very high for this reaction. addition of steam. Okay, guys, I would like to change the board here, and I am writing the central idea of this reaction here. Alkenes. Okay, alkenes are there. Okay, and now I am telling you that these are the three types of the product. Guys, I am making this flowchart so that things can become easier for all of you. So here it is just making, these are the three types of the products. So alkenes, when they are going to react with hydrogen, they are going to make alkanes. Okay, alkanes. Okay, when they are going to react with halogen are the elements of group number 7. What are the elements of group number 7? Fluorine, chlorine, bromine, iodine, astatine, and a new element is added in your periodic table if you have seen, that is called tennessine at the end of the group number 7. Now, as the new element is added in group number 7, so examiner can ask this thing, that how many electrons will be there in the outermost shell of that element, that is tennessine. You should know this thing, that as it is added to group number 7, so it will have how many electrons? 7 electrons in its outermost shell. Now, it is a non-metal, just like chlorine and bromine. So it is now going to gain the electron when it is becoming a participant of ionic bonding. One more thing is this, that going down the group, the color is getting darker in group number 7. So this element will be black in color. Then there is another question, that going down the group, the state is getting changed, solidification is developing. So we can say that the upper element, fluorine and chlorine, are the gases, bromine is liquid, iodine, astatine, and tennessine will be solid in the nature. Okay, so I have just revised those properties with you. So when halogens are going to attach with alkenes, they are going to make haloalkane. Haloalkanes are also called as halogenoalkane. Halogenoalkane. Yep. This is not that halonessa, by the way. Okay. So haloalkanes or halogenoalkanes are the same thing. What are these? It is the combination of a halogen with alkane. Okay. Guys, there is a third one, and that is the reaction with steam thingy. Here I am writing the gas. The symbol for the gas is G. Okay. So it is now going to make alcohol. Yes. Okay. And how it is? I'm going to tell you all these things in detail one by one. Now I am on the first thing, and that is the reaction number 1. Reaction of, here there's the heading, reaction of hydrogen with alkenes. Okay, with alkenes. Okay, so this is this, and this is this. Okay, I can tell you that, for example, what is the catalyst for this reaction? If you are performing this with the catalyst nickel, then you have to keep the temperature from 300 degrees Celsius to 450 degrees Celsius. For example, sometimes in the books it is 250 degrees Celsius to 400 degrees Celsius. So 300 degrees Celsius is an optimum temperature which you can write. Okay, and if you are taking a better catalyst, which is platinum or rhodium, guys, please be careful about these all catalysts, platinum or rhodium, then in that case, the reaction will be occurring at the room temperature. Okay, at the room temperature. Now, one more thing which I would like to tell you, that the double bonded carbon atoms are now going to welcome the hydrogens. Okay, so just check this thing, that this is a 3 carbon atom chain, and how many hydrogens are there with this? 3 hydrogens. It will have 1 hydrogen and it will have 2 hydrogens. So when it is going to attach with hydrogen gas, as a result of that, the carbon atoms of the chain will be remain as it is. The double bond will be shifted into single bond. The previously present hydrogens will be remain as it is, and the newly coming hydrogen atoms are going to attach across the double bond, across the double bond. I am saying this thing again and again, across the double bond. Be very careful about that. Okay, so here I am going to change the board, and I am bringing you here. I can say this thing, this is carbon, 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 and carbon. Okay, so this is a four carbon atom chain and the double bond is here. Okay, so here it is H3, here it is H, here it is H, and here it is H3. Guys, again and again and again, I'm telling the same point. And what is that? Across the double bond, across the double bond, remaining carbon atoms will not gain any incoming party. Remaining carbon atoms are not going to welcome any incoming partner. Okay, so you can say this thing that there is hydrogen over there, and as a result of that, what is happening? One carbon atom, second, third, fourth, the double bond will be shifted into the single covalent bond. You can see this thing, the two hydrogens will come just across the double bond, and the remaining hydrogens will be remain as it is. So no difference will occur. Only the two reactants are going to combine with each other to make one product. That's why the name is addition reaction. Addition, it is going to add up. Okay, so addition is happening. Now I'm going to give you an example in which there will be more than one double bond, just to tell you that this can be a possibility as well. Okay, so here there is H2, here it is H2, here it is H, and this is H2, and it is going to attach with 2H2. Why 2H2? In case of H2, how many hydrogens are there? Two hydrogen atoms. In case of 2H2, how many hydrogen atoms will be there? 2 into 2, 4. So 4 hydrogen. Look, one hydrogen will come here, one hydrogen will come here, third hydrogen will come here, and the fourth hydrogen will come here. One more thing which students can have in their mind, that can we attach this hydrogen at the lower side and this hydrogen at the upper side as well? Yes, you can attach it. So this is not making any difference, but remember this thing, only those hydrogens are the receivers which have the double covalent bond. Okay, so here I am going to write down the reaction. The product will be 1, 2, 3, 4, 5. The double bond is shifted into single bonds. Remaining hydrogens will be as it is. So this is the product, and you can see this thing, that what is the product here? H and H, H and H. Guys, I would like to tell you again that there will be a proper naming lecture. Not, I guess, not only one lecture. I guess I have to take 2 to 3 lectures for naming. I will describe you the rules of naming regarding organic chemistry, and how to develop the compounds name, and how to develop the alkanes and alkenes name, inshallah. Okay, take care of yourself. We have finished the first reaction. I will pursue the next lecture, inshallah, from the same point. Thank you very much.